Okay, hang in there, just a few more examples and we'll wrap this up. So 15, so this is the integral of e to the cosine x power sine of x dx. So we're thinking u is going to be cosine x, good. Cosine x, so then what would the derivative of cosine of x be? Negative sine x dx, so when we rewrite this, we'll have e to the u du. Now, the u is accounted for, so that's good. Sine of x dx is here, but what about this guy? Yeah, we just need to pull a negative out front, so good. Now we just bring that down and evaluate this. The antiderivative is just e to the u plus a constant. And then lastly, we can substitute for u and have cosine of x there. And not too bad. Alright, this next one, integral of cosecant x times 1 minus cosecant x dx. Nothing really standing out to me. One of the things that we can do is use algebra to distribute this and see if that makes anything look a little more familiar to us. So cosecant x times 1 is just going to be our cosecant x. And then we would just get cosecant squared x dx. Okay, so now this, if I break this apart individually and do this one, this is one that we learned today. So this one is just going to evaluate to the natural log of cosecant x minus cotangent x. Whoops. Let me fix that. And then the integral of cosecant squared x is just going to be negative cotangent x. And then we have plus a constant. Alright, so and then we could rewrite this minus a negative. So we could do one more step and just natural log cosecant x minus cotangent x plus cotangent x plus a constant. So no u substitution there. So you want to just be real careful when you have trig functions. If we know the integrals of ones in particular right from the get-go, or here, in this case here, and the squared one, then you probably want to head towards that direction. And we only use u substitution when we have to. Okay, so let's do an application. So we're going to find the area of the region bounded by the given information. So we have our y equals 2 tan x, y equals 0, x equals 0, x equals pi 4. Okay, so if I write my area formula down, I'm just going to say area is equal to what's our limit's going to be. So it's going to be our intervals from 0 to pi 4ths. And our first function, our f of x, is 2 tan x, and the other one's y equals 0, so that's just going to be a 0. So basically it's going to be 2 tangent x dx. Okay, so let's go ahead and evaluate this. If I pull this 2 out, that would give me a 2. What is the integral of tangent x? Negative natural log of cosine of x, and that's going to be evaluated from 0 to pi over 4. Okay, so we're going to pause it and let you go ahead and set that up and do your calculations. Okay, so we plug in our formula here, so 0 to pi 4ths, f of x is 2 tan x, and then the g of x is just 0, so we have this. Pull my 2 out front, the integral of tangent x is negative natural log cosine of x, evaluated from 0 to pi 4ths. Okay, we plug in the pi 4ths and the 0. At this point we go to the unit circle. Cosine of pi 4ths, this is the x value at pi over 4. The non-simplified version is 1 over the square root of 2. If you use the simplified unit circle, it's the square root of 2 over 2. Both equivalent. Cosine of 0 is just 1. Okay, I rewrite just this term. Bring down the negative, natural log of 1. Remember, division you can rewrite as subtraction, but if I have a negative that's distributed here, a negative times a negative will give me a positive. So hopefully that wasn't too many steps at once for you. Natural log of 1 carried down. Natural log of 1 is just 0. Bring this guy down. Natural log of 1 is just 0. Right here, you can get this answer in your calculator from here, but if you wanted an exact answer, we'd do some more simplifying. This is 2 to the 1/2 power. So if I took that 1/2 and moved it out front, it would be 1/2 natural log of 2. This 2 times the 1/2 simplifies to just the natural log of 2, which is 0.69, and since we're talking about area, let's just say units squared. Okay, and our last example for today is a volume. So given secant x from negative pi thirds to pi thirds between y equals 0, revolving about the x-axis, we're going to suggest this method. So our formula for volume is just going to be pi f of x squared dx. So take this as far as you can. I'm going to give you a fair warning that I'm going to actually use the symmetric form of this just so I can use that 0, but you should get the same answer regardless. So just so you can see the area, I'm going to use symmetry, and I'm going to say 2 times this area to calculate this whole thing. So I can use 0 and pi over 3. Okay, let's check our answer on this. So first thing, let's evaluate pi, and then our f of x is secant of x squared, and then we're going from negative pi over 3 to pi over 3 dx. Now here's where I rewrote it using symmetry, because I pulled out the 2 and then I changed this to a 0 to pi half. So I'm just going to do the right hand side and then multiply that by 2. Okay, so now I'm ready to, I bring my 2 pi and I evaluate the integral of secant of x squared is tangent of x, and then I plug in the pi over 3 minus tangent of 0. You go to the unit circle and your tangent is your sine over your cosine, so it's your y value over your x value at this position. Algebraically, you simplify this and it's going to reduce to square root of 3. Tangent of 0 is just 0, so we just get 2 pi times the square root of 3, which is approximately 10.88 units cubed since its volume. So we can also extend this to applications, and this was revolved about the x-axis, and we chose to use this method.